Hi friends, in this video we are going to discuss about how to find eigenvalues and eigenvectors of a matrix, and that matrix is obtained from a linear transformation. So let me see one example. Let T be a linear operator on P2 of R defined by T of f of x equal to f of x plus x plus 1 into f dash of x. Let beta be the standard ordered basis for P2 of R. Then find the eigenvalues and eigenvectors of the matrix A equal to the matrix T over beta. So this is a question. So let me see how to solve this question. How to frame a matrix A first, then how to find the eigenvalues and eigenvectors later. So first, the given transformation is T from P2 of R to P2 of R. So that's why this is called linear operator. So linear operator is nothing but the domain and codomain are same sets. So here the mapping goes from P2 of R to P2 of R, that is defined by T of f of x equal to f of x plus x plus 1 into f dash of x. So this is the way we define that function, and let beta be the standard ordered basis for P2 of R. So that is given in question. So we have to take the basis of P2 of R. So P2 of R is nothing but the set of all second degree polynomial. Second degree polynomial means the highest power of x is 2. So that polynomial definitely should contain x squared term or x term. Definitely this term should be present. With that, x term may be include or some constant may be include. Any constant a we can include. So here generally the basis elements are 1, x, x square. So this is the basis element of P2 of R. Using these three vectors, we can create any polynomial of degree 2. So here any constant a is created by using 1. 1 into a equal to a. So using 1 we can generate any constant. So that's why 1 is a element in a basis. So 1, x, x square are the basis elements to generate a set of all vectors P2 of R. Now this is our basis. Now using this basis and using this definition of t of f of x, we need to find a matrix. So shall we proceed here? First take t of f of x. So t of f of x means this is the input. So from first set you have to take the element. So first set is here. This is the basis elements from the first set. So take the basis element 1 here. So t of 1 equal to, see the definition tells t of f of x equal to, that f of x you have to write as it is, then write x plus 1, then f dash of x you have to take. In these two places only you have to use that f. Here directly you have to use this f, and here you have to differentiate that f. With that you have to multiply x plus 1. This is the function we define. Right, now take first element t of 1. So here 1 means first take 1 as it is. Now 1 is your function f. So first f write as it is. What is f of x is given. F of x is now constant 1. So write that constant. Then x plus 1 into f dash of x. Our f of x is 1. So differentiation of 1 is 0. Constant differentiation is 0. So this implies we can get 1. Here 0 and anything is 0 only. So the answer is 1. Now we need to express this 1 as the linear combination of the second set basis. Here second set also P2 of R, that basis also 1x x square only. Therefore this 1 can be expressed as 1 into 1 plus, so here x and x square terms are missing, therefore we can include that 0 into x, 0 into x square. So we need to express this element in the linear combination of 1x x square, and the value also should not change. So see here, if we calculate this expression, we can get the answer is 1. This answer you can get. So 1 into 1, and remaining coefficient of x and x square we can take 0. So this is the way you have to write a linear combination for this. Next take next element t of x equal to write the element as it is, x plus, next x plus 1 into differentiation of this x. Differentiation of x is 1. So that is our definition. Therefore here the answer is x plus 1 into x plus 1 is x plus 1. So that is equal to 1 plus x plus x is 2x. So this is a resulting value of t of x, and this element also can be written as linear combination of 1x x square. Here already 1 and x are present, so write here as it is 1 into 1 plus 2 into x plus x square term is missing, so add that term 0 into x square. That's it. Next go for next element t of x square. So 1 and x are over, now come for x square. So t of x square means first write the element as it is. By the definition t of f of x equal to f of x, you have to write as it is, plus x plus 1 into, now we have to differentiate this function, derivative f dash. So here f dash is nothing but x square differentiation is 2x. So that is equal to x square plus, just multiply this inside. So 2x into x is 2x square, 2x into 1 is plus 2x. So that is equal to 2x plus 2x square plus x square is 3x square. So here also we are having x term and x square term, one term is missing, here constant is missing, so you have to multiply 0 with that. 0 into 1 plus, write 2x and 3x square as it is. So those are the terms here occurs, that term you have to take as it is. Missing term you can take 0 coefficient. That's all. So we found all the values of t of 1, t of x and t of x square. Now we can write the matrix. Therefore the matrix A equal to the matrix T over beta. So this is nothing but, just take in t of 1, just take the coefficients for this and write column wise 1 0 0, and second element 1 2 0 1 2 0, in third element 0 2 3. Write that coefficient as column wise. So this is the matrix of the given transformation. For this matrix we have to find eigenvalues and eigenvectors also. So that's also a very simple idea. So by the property, this is nothing but a triangular matrix. For the triangular matrix whose eigenvalues are the main diagonal elements. So using that property easily we can get our eigenvalues. Otherwise if it's not triangular matrix, you have to use the general idea of eigenvalue eigenvalue problem. That means you have to apply determinant a minus lambda I equal to 0. That formula you have to apply. So from that method also we can get the same answer. So now I apply the property. Now by property, the eigenvalues of a triangular matrix are the main diagonal elements, or the main diagonal elements. Therefore, the eigenvalues of A, here A is a triangular matrix, therefore the eigenvalues of A are whose diagonal entries 1, 2, 3. So these are the eigenvalues for this matrix. So the actual way is you have to apply determinant A minus lambda I equal to 0. So using this method also we can find, actually this is the original method. For this problem we have triangular matrix, so easily we can find by the property. Right, next our aim is to find eigenvectors. To find eigenvectors, to find eigenvectors we need to solve one equation. Solve the equation a minus lambda I into x equal to 0. So this equation we have to solve. Here lambda is the eigenvalue and x is the eigenvector. This eigenvector only we are going to find. So here a minus lambda I is simply we can write. See what is a is given, or what a we are having. In that a, just subtract lambda to the diagonal, so we can get a minus lambda I. Therefore 1 minus lambda 1 0 0 2 minus lambda 2, then 0 0 3 minus lambda. So this matrix is nothing but a minus lambda I into x. X is nothing but a column matrix. This is x1 x2 x3 equal to 0. Now take this is equation number 1, is a main equation. So here we come one by one. So first take lambda equal to 1. This is our first eigenvalue. For this eigenvalue, what is the eigenvector we can find? So these are our eigenvalues 1, 2, 3. So for these eigenvalues we have to find eigenvectors. Each and every eigenvalue should contain one eigenvector. So we need to find here 3 eigenvectors. First we move for lambda equal to 1. Substitute lambda equal to 1 in that first equation. In that Roman letter 1, substitute that. So we can get 1 minus 1 0, 1 0 0 1 2 0 0 2. So this is a matrix we can get. So x1 x2 x3 equal to 0. Now create the equation from this. So what is the equation you can get from this? 0 into x1 0 into x1 plus 1 into x2 plus 0 into x3. That means simply you can get x2 equal to 0. Next equation 0 into x1 plus 1 into x2 plus 2 into x3 equal to 0. Okay, take like this and multiply like this. There is a way you have to multiply. So 0 x1 1 x2 0 x3, that is x2 equal to 0. X2 only we can get. Here 0 x1 is 0, 1 x2 plus 2 x3 equal to 0. Then last also 0 x1 plus 0 x2 plus 2 x3 equal to 0. So from this equation, from the third equation we can get x3 equal to 0. Here already x2 equal to 0. Here also we are having only x2 and x3. That means here x1 is free variable. So here x1 is free variable or x1 is arbitrary. Arbitrary means we can take any value to x1. That is the meaning of arbitrary. So I will choose let x1 equal to 1, the smallest value we can take. Therefore the first eigenvector x1 is 1 0 0. So this is your first eigenvector for eigenvalue lambda equal to 1. Next case 2, lambda equal to 2. For lambda equal to 2, again you have to substitute in equation number 1. You can get one coefficient matrix. So substitute here lambda equal to 2. That means you can get minus 1 1 0 0 0 2 0 0 1. Minus 1 1 0 0 0 2 and 0 0 1. So this is the matrix you can get if you substitute that lambda value in equation number 1. Now the x value is x1 x2 x3, that's equal to 0. Now again create the equation here. So minus x1 plus x2 plus 0 x3, okay, equal to 0. So just leave that 0 x3. Then next row is 0 x1 0 x2 plus 2 x3. So 2 x3 equal to 0. Similarly for next row also 1 x3 equal to 0. So from the last two equations we can get x3 equal to 0, one result, and from this equation we can get x1 equal to x2. We got one relation. So we can take let x1 equal to 1. So x1 equal to 1 means this implies x2 also 1 because x1 equal to x2. So therefore the second eigenvector is x1 1, x2 1, x3 is 0. See, this is any number we can take, no issues. Least, if you choose least number, then the further calculation will be easy. So for that we are choosing the least value 1. So x2 equal to 1 1 0. We cannot choose x1 is 0 because we choose x1 0 here, x2 also 0 because already x3 0. Therefore we are going to get 0 0 0 as a vector. Eigenvector should not be a 0 vector, so you should careful about that. So always eigenvectors are non-zero vector. Right, next case 3. For case 3, lambda equal to 3, we have to substitute in equation number 1. So if you substitute lambda equal to 3 in equation number 1, you can get minus 2 1 0 0 minus 1 2 0 0 0. Last row will be 0. So the value is minus 2 1 0 0 minus 1 2 0 0 0 into x1 x2 x3, that's equal to 0. Now again create the equation from this. Minus 2x1 plus x2 plus 0 x3 equal to 0. Then minus x1 is 0 here, then minus x2 plus 2x3 equal to 0. And last row we cannot create any equation because all the elements are zeros. So from this we can get 2x1 equal to x2, and from this we can get x2 equal to 2x3. So from this equation I am going to choose see these both equations are depending on x2, so I will choose x2 equal to 1. So if I choose x2 equal to 1, we can get x1 equal to 1 by 2. So if we get x2 equal to 1, we can get x1 equal to 1 by 2. So to avoid that 1, choose x1 equal to 1. Suppose if I choose x1 equal to 1, we can avoid 1 by 2 answer, rational answer we can avoid. So I will choose x1 equal to 1. So this implies we can get x2 equal to 2. If I choose x1 equal to 1, we can get x2 equal to 2. x2 equal to 2 means we can get x3 equal to 1 from this equation, or simply you can use these two equations 1 and 2. From 1 and 2, 2x1 equal to x2 and x2 equal to 2x3. See, both are equal to x2. So from 1 and 2 we can get, from 1 and 2 we can get 2x1 equal to 2x3. So 2 to get cancelled, therefore x1 equal to x3. This equation, this relation we are going to get. So now fix x1, that x1 only I fixed here. So x1 equal to 1 means we can get x2 equal to 2. x1 1 means x3 also 1. This implies x3 also 1. Since the reason is x1 equal to x3. That relation only we got by comparing 1 and 2. So this is the way we can get the values of the third vector. So x3 equal to, third eigenvector is x1 1, x2 2, x3 is 1. So 1 2 1. This is your third eigenvector. Therefore, the eigenvalues of A are 1 2 3, and the corresponding eigenvectors are x1 is 1 0 0, x2 is 1 1 0, and x3 we got 1 2 1. So that's all. So this is the problem, that one. So we will see another problem in next video. Thank you.